Hello and welcome to NoelRecords Programming Lab. I've mentioned this in my short videos, but I recently bought a microcontroller called the Raspberry Pi Pico WH. It's mainly used for educational and learning purposes, and while it's low cost and doesn't have an OS, it can run a specified program at startup and do a lot of things, making it surprisingly convenient. I've been experimenting with the Raspberry Pi Pico for a while, but I decided that I wanted to get a higher-end Raspberry Pi. The latest models were a bit pricey for just playing around, so I bought an older model, the Raspberry Pi 3B. The storage is an SD card, and it runs Raspberry Pi OS. Since it runs an OS, it can do a lot of different things. So, I've decided to make a night vision child monitoring camera, something I've wanted for a while. With this, I can check on my sleeping child from my smartphone even with the lights off in the room. Please watch until the end if you're interested. First, let's go over the equipment we'll be using. We'll use a Raspberry Pi 3B. This model was released in 2016, so it's quite old. I recommend getting a newer model like the Raspberry Pi 5 if you're purchasing one now because it's easier to find and has better performance. We'll use a micro SD card for the Raspberry Pi's storage. I have a 32GB one ready. Next, we need a night vision camera. I bought mine from AliExpress, but the same one is available on Amazon. We'll also need a power cable and a computer for the initial setup and remote configuration of the Raspberry Pi. The computer can be either Windows or Mac. The library we'll be using is MJPG-Streamer. MJPG-Streamer is a library that can stream captured video over a network. With this, you can view the camera feed in real time from a browser on a computer or smartphone. Unfortunately, it can't stream audio, but for our purposes, that's fine. I tried several other libraries, but MJPG-Streamer was the simplest and had the least delay, even on an older device like the Raspberry Pi 3B. We'll use these to build our child monitoring camera. Let's get started. First, access the Raspberry Pi official website from your computer. Click on Software at the top. Scroll down a bit, and you'll see the download button for Raspberry Pi Imager. Click it to download and install. Launch Raspberry Pi Imager and connect your micro SD card to your computer to write the OS. In the Raspberry Pi device section, select the model you'll be using. Since I'm using a Raspberry Pi 3B, I selected Raspberry Pi 3. Next is the OS section. Raspberry Pi OS has graphical versions like Windows or Mac OS, which are more convenient for general use. If you have a newer Raspberry Pi, select the top option, Raspberry Pi OS, 64-bit. However, since my Raspberry Pi 3B is quite old and low performance by today's standards, I'll be using Raspberry Pi OS Lite, 64-bit, which doesn't have a GUI and is operated entirely from the terminal. Select the SD card to write the Raspberry Pi OS. You'll see a dialog asking, "Would you like to customize?" Although you can configure these settings after writing the OS, it's easier to do it now, so click Edit Settings. In the General tab, set the username, password, and Wi-Fi connection details. Don't forget to set the Wi-Fi country to your own country. In the Services tab, check Enable SSH. Enabling SSH allows you to operate the Raspberry Pi securely from another device. I'll choose Use Password Authentication for this setup. Save the settings and click Right to write the Raspberry Pi OS to the SD card. Depending on your computer, you might be prompted for a password or administrator privileges. Wait until the writing process is complete. Now the Raspberry Pi OS is written to the SD card. Let's set up the Raspberry Pi. Insert the micro SD card with the Raspberry Pi OS written on it into the Raspberry Pi. For the first boot, you'll need to do some setup. So connect a USB keyboard and display. Connect the power cable to start the Raspberry Pi. It will boot automatically. The initial setup will begin. Let it run for a while. After a few reboots, you'll be prompted to log in. Log in with the username and password you set earlier. Once logged in, if you installed a GUI version of Raspberry Pi OS, you'll see the desktop screen. Open the Terminal app to continue the setup. Check if you're connected to Wi-Fi by typing ifconfig val on 0. If you see the IP address and other details, everything is fine. Next, set up auto login. Type sudo raspi-config. You'll see a dialog like this. Use the arrow keys to navigate to System Options and press Enter. Then select Boot, Auto Login and press Enter. If you're using a terminal-only version like me, select Console Autologin and press Enter. If you have a GUI version, select Desktop Autologin and press Enter. Once the setup is complete, you'll return to the initial screen. Press Escape to exit raspi-config. To check if auto login is enabled, reboot by typing sudo reboot. The Raspberry Pi will reboot. If it logs in automatically, the initial setup is complete. Type sudo shutdown now to turn off the power temporarily. Now that auto login is enabled, let's connect the night vision camera to the Raspberry Pi. Look closely at the Raspberry Pi's board, and you'll see a camera port labeled camera. Connect the night vision camera's ribbon cable here. Lift the camera port's clasp to create a gap. Insert the ribbon cable into this gap, ensuring the metal contacts on the camera port and ribbon cable align. Push the clasp back down to secure the ribbon cable. The night vision camera is now connected to the Raspberry Pi. Now, without connecting the keyboard or display, just plug in the power cable and start the Raspberry Pi. Next, connect to the Raspberry Pi remotely from your computer. Open the Terminal app on a Mac or Command Prompt or PowerShell on Windows, and run the following command. For this example, the username is NoelRecords, so the command is ssh NoelRecords at raspberrypi.local. The first time you connect via SSH, you'll be prompted to confirm. Type yes and press enter. Enter the password you set when writing the OS to the SD card and press enter. Now you're connected remotely. This way, you can operate the Raspberry Pi without a keyboard or display connected, which is convenient. Let's check if the Raspberry Pi recognizes the connected night vision camera. Run the command libcamera hello T0. The terminal will scroll rapidly. Press Ctrl+C after a while to stop the process. This command is like the hello world of cameras, confirming the camera is working. Since we're using a terminal-only version of Raspberry Pi OS and SSH, the camera preview won't appear. But as long as you see the camera information, it's okay. The camera is recognized, but you can't control the camera connected via the ribbon cable with programs in its current state. Run the following command to enable the legacy camera. Enabling the legacy camera allows you to control the ribbon cable camera with programs. Restart to apply the settings. Connect to the Raspberry Pi again via SSH. Now let's install the necessary packages for the night vision child monitoring camera. First, update the installed packages. Run the commands sudo apt update and sudo apt upgrade y. Wait for the update to complete. Once the package update is complete, install the necessary packages. Install git, cmake, and libjpeg-dev with the following commands. Installation is complete. Now let's build MJPG-Streamer from source. We'll work in the home directory. If you've followed the video so far, you should be in the home directory. But run the command to move to the home directory just in case. Download the MJPG-Streamer source code. The original project is no longer being developed, but there are several forks maintained by volunteers. I'll use a relatively recently updated repository. The URL is in the description. Clone the project from this repository. Move to the lower directory MJPG-Streamer Experimental. Build with the make command. Once the build is complete, let's test it. MJPG-Streamer is run with command input, but there's a test shell script provided. Run it with start.sh. From a computer or smartphone connected to the same network as the Raspberry Pi, access raspberrypi.local:8080. You'll see a screen like this. Click Stream in the left menu to view the video. The night vision camera makes everything look reddish. The delay is relatively low. The screen has instructions for using MJPG-Streamer in English, but since we only want the video, move to the URL provided. Now you only see the video from the camera. To stop MJPG-Streamer, press Ctrl+C in the terminal. The program has stopped. Now we've made a night vision child monitoring camera with MJPG-Streamer. But connecting via SSH and running the startup script every time you use it is cumbersome. So let's automate it so that the night vision child monitoring camera runs automatically when the Raspberry Pi starts. There are several ways to run a program automatically on startup with the Raspberry Pi. But I'll show you the relatively simple method of editing rc.local. By writing commands or scripts to /etc/rc.local, they will run when the Raspberry Pi starts. Let's check the contents of rc.local with the following command. You'll see exit 0 at the end of the file. Write the command or script you want to run at startup before this exit 0. In this case, we'll create a script to run the night vision child monitoring camera and write it here. Specifically, create a shell script to run the night vision child monitoring camera called startcamera.sh. Create this shell script in /user/local/bin/. Then write startcamera.sh before exit 0 in rc.local. Let's do it. First, let's look at the contents of start.sh, which we ran for testing earlier. There are many lines, but most of them are commented out. The actual working code is like this. Surprisingly little. Let's see what's written. The first line, starting with hash, is called a shebang and specifies which interpreter to use to run this script. This notation means it will be executed with sh, the Bourne shell. The next line specifies the path to the MJPG-Streamer library. Start.sh is in the same directory as the MJPG-Streamer library, so the current directory is specified. The last line is the command to run MJPG-Streamer. The I option specifies the input plugin for MJPG-Streamer, and the O option specifies the output plugin. That's what's written in start.sh. The startcamera.sh we'll create now should work with the same content, but since the script's location will change, it will cause errors if used as is. Rewrite the paths to full paths when specifying libraries and such. First, create the startcamera.sh file in the following directory. I'm using Nano as the text editor, but Vim or any other editor is fine. Write the shebang. Write the full path to the MJPG-Streamer library. Replace the username and the full path with your own. Create a variable called streamer and store the full path to MJPG_streamer. Use these variables to rewrite the execution command. Save and close the text editor. Now let's check if startcamera.sh works correctly. Run the shell script with the following command. Everything seems fine. Finally, register startcamera.sh in rc.local. Let's check if it's registered correctly. Run the following command. It didn't execute and return permission denied. It seems the created startcamera.sh doesn't have execution permissions. Grant execution permissions with the following command. Run it again. Okay. Now let's restart the Raspberry Pi and check if MJPG-Streamer runs automatically without SSH. It's starting automatically. No problems. It's complete. I tested the night vision child monitoring camera in a completely dark room. When taken with a smartphone camera, it's so dark you can't see anything. But with the night vision child monitoring camera, it's this clear. I used it at night to watch my sleeping child, and I could clearly see their face. Unfortunately, it doesn't stream audio, but just being able to see the face is reassuring. By accessing this URL, you can view the night vision child monitoring camera's footage on a PC, smartphone, or tablet. It needs to be on the same network, meaning the same Wi-Fi. But it's easy to view from a browser, which is convenient. In my experience, the video never cuts out, but to be sure, I use the OpenCV plugin to display the time on the night vision camera's feed. With the OpenCV plugin, you can process the video before passing it to MJPG-Streamer, so you can check if the feed stops. However, building the OpenCV plugin is a bit tedious, and it took about 8 hours to build on my Raspberry Pi 3B, so I'll just briefly introduce it. For automation, I used rc.local, but it's officially recommended to use systemd. It's not too difficult, so try automating with systemd if you're interested. Although I automated the startup, I still need to connect via SSH to shut down the Raspberry Pi. The Raspberry Pi doesn't come with a power button, so you could just unplug the power cable, but that's a bit worrying. The Raspberry Pi board has many PO pins. By configuring these and connecting certain pins, you can shut down the Raspberry Pi. By connecting these pins with a tactile switch, you can easily turn off the power with a button. This significantly improves convenience. I haven't made the power button yet, but I plan to do it soon. That's all for this video. Please support us by subscribing and liking if you enjoyed this content. I read all comments, so please leave your thoughts. Also, check out our social media. See you in the next video. Thank you.